Okie dokie. So now, here's what we start. We're going to start with the acceleration due to gravity. If this is the acceleration due to gravity, let's start with that as our second derivative. By the way, if I didn't mention it, our second derivative is always acceleration. Because then if we go up a level, our first derivative will always be velocity. And our original function will be our position function in this unit, at least for what I'm going to teach you. Mr. Lake will go further. Okay? So now I'm going to try to find the velocity formula, and this is what I'm going to do. I'm going to integrate that thing with respect to time, and that will give me the velocity. That's why there's only one prime there. When I do that, I get that it's negative 32t plus the constant of integration. Now this is where it gets a little confusing. With what minimal initial velocity must an object be thrown upward from ground level? This constant of integration, I'm going to call it something else. I'm going to call it v sub 0. Because I don't know if you realize this, but in all the previous problems that we've had, that middle number was always your initial velocity. So this constant, I don't know what it is. I still don't know what it is, but I'm going to call it v sub 0 at this point so that I don't get it confused with the other constant of integration. Earlier I called them C1 and C2. Now I'm going to call it v sub 0. And the other one I'm going to call something else, which you'll see in a second. Let's integrate this. Let's integrate it so I can get to the position formula. And there's, golly, why don't they wait with respect to time? Now that we do that, we go up a level, add 2, divide by that 2, you get negative 16. This goes with respect to time, plus this constant of integration, which is c. I'm going to rename this something different too. This is s sub 0. This is our starting height. That starting height, if I'm shooting an object from ground level, then our starting height has to equal 0. So I can plug in 0 for that particular thing. The question says, with what minimal initial velocity must an object be thrown upward from ground level to reach the top of the rack, which is 32 feet. By the way, this is the Rene Roddenberry Center. That's the top of the gym, the East Gym, and I was trying to see how much force is required to shoot something up on top of that building. Maybe a water bottle. I'm not sure. Okay. So what I'm going to do now is I need to figure out what velocity it's going to take to reach 32 feet. Look at this equation. I want to know I'm going to take this equation and I want to figure out when the velocity is equal to 0. Let me give you a little picture. If an object goes up, it goes up, it goes up, and then it starts coming down. When an object goes up, it stops going up eventually, kind of like goes and it gets shorter, 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 and then it stops and then it starts going down. It starts accelerating downward. So what I'm going to do is I'm going to take my velocity. Where is the velocity equal to 0? The velocity is equal to 0 at the top of the parabola. Now, let's figure out what time it takes for it to reach a velocity of 0. I want to figure out what time it takes to get to the top of the parabola. That's what I'm going to do here. Let's subtract this, or add the 32t. And let's divide by t. And now I know this is the time it takes to get to the top of the parabola. That's when your velocity is 0. The velocity is accelerating, and it's actually decelerating, gets to 0, and then it starts accelerating negatively going downward. This is the time it takes to get to a velocity of 0. What we can do with this is we can now plug in this time into our position function. So what I'm going to do is I have my position function, and it has to reach a position of 32 feet off the ground. So I'm going to put the 32 in to this s of t function. 32 equals negative 16t squared plus the initial velocity times t. This is what time when position is 32 feet. And we know that I know what time it takes to get to that if I plug that in. That gives me a velocity of 0. Let's plug that in for t to both places. This looks crazy, but let's do it. Negative 16 v naught over 32 squared plus v sub 0 times v sub 0 over 32. It looks like I'm going nowhere, but trust me, it is getting better. It really is. Square it. Top times the top. This is what you get next. I squared the 32. 32 times 32. But I can also, 16 goes into 32 2 times. 2 times 32 is 64. There you go. That's what it's going to be. These do not have the same denominator. If I multiply by 2, I can get a common denominator, and then 2v sub 0 squared over 64 minus 1v sub 0 squared over 64 is v sub 0 squared over 64 equals 32 times by 64. Boom. Square root. Boom. This is your initial velocity that you have to reach the top of the parabola. And which is about 45.2 feet per second. This is as hard as it gets. So those of you who I am hearing, this is kind of like an AP prep question. Yes, exactly. This is very similar to what you would have on an AP prep question. Okay? Well, that's it for my notes. I hope you understood what you're doing, and good luck on the homework. See you next class.